In this demo, I will demonstrate what happens when a method returns the value of a reference type. I'll use the very commonly known toString method to illustrate this. Now, this demo uses the string class. If you want to know more about strings, have a look at some of my other videos. Okay, the code I'll use consists of two classes: a rectangle class with four properties, x, y, height, and width, plus a toString method. Now, toString is a method that is inherited from the implicit base class called objects. It is recommended to override this method. It must return a string. Stated more correctly, it must return a reference to a string object. And the string object returned is a string representation of the current state of the rectangle object on which toString is called. In this example, a new string object is constructed using string-method, in which the current values of the properties are inserted. Let's see this at work with the second class, the client class rectangle app. Here I create a rectangle object using a 4 arguments constructor, not displayed in the rectangle class, rather symbolized by the other code comment, since it is irrelevant for this demo. The arguments represents 1 for x, 2 for y, 10 for height, and 20 for width. Then executing system.out.println rect1. Although not clearly stated, this statement implicitly invokes the toString method on the rectangle object rect1. When the call from toString returns, the returned string is directly printed out by the client, who will see following information appear on the screen. Now, the client code I illustrate here uses a compact notation. To explain what happens under the hood, I'll use a more extended syntax that looks like this. Here in the client class, the toString method is explicitly called on the rectangle1 object reference. The return value is assigned to a temporary value rect1 state, which is then printed out. The result will be exactly the same, but things should be more clear when I explain it using this extended syntax. As an extra for this demo, note that when executing string.format, I use a mix of two notations, namely using this dot followed by a data member, x in this case, and no this dot, but using remaining data members directly. Let's see whether this has an impact in memory when we use the this notation or not. And let's examine how invoking toString is implemented in the memory layout. The stack frame of the main method is already set up. Then the creation of a rectangle object, which implicitly invokes the 4 arguments constructor. So allocation of the local variable rect1, and then the object creation on the heap. Rect1 refers to our object located at fictional address 1000. Then the invocation of the toString method, and the result is assigned to this new variable rect1 state. So first the allocation of that variable, and then the invocation of the toString method. Now, when toString is invoked, a new stack frame is created for this method. This stack frame now becomes the current stack frame. Our method has no parameters. Still, space for a local variable will be allocated in the local variables array of the current stack frame. That'll be the this pointer, as explained in a previous demo. Since in the main method toString is invoked on the object referred to by rect1, a copy of that value, so the address of our object, will be stored in the local variables array at the first position, denoted by an implicit variable called this, or the this pointer. It receives a copy of rect1. As a result, this points to the rectangle object as well, and so we have access to the object from within the toString methods. Okay, the stack frame is set up. Then the return statement. First we construct the string using the string.format, and an entirely new object will be created on the heap, not in the string constant pool, since it is constructed at runtime. And its content represents the current state of object rect1, and is located at fictional address 1500. Now, due to lack of space in my slide here, I only display how X and Y are used, but implicitly I construct the string using all four properties as mentioned in the previous slide. And the result is that following string is constructed. Now, what about this dot notation? Well, if there's no name ambiguity, I mean if there's no other parameter or local variable within the scope of the toString method bearing the same name as a data member, then it doesn't matter whether you use this or not. So in the case of Y, the Java virtual machine interprets that as being this.y anyway. It implicitly prepends this to the name of the data member or property. Okay, then since there is a return statement next to the local variables array, but still in the stack frame, is where the return value of the method is stored. It is the content of this memory location that receives the value of 1500. And so the return value contains a reference to the string objects. That's all for these methods. When the return takes place, we leave this method and the return value is assigned to the rect1 state variable that was allocated in the stack frame of the main method. This assignment takes place now. toString is no longer being executed, so the stack frame associated with it is removed, and we're back at the stack frame of the main method, which now becomes the current stack frame. If we would print out the value of rect1 state now, then we would see the following value on the screen. So to resume, whenever a method returns a reference type, what is returned to the caller is the address of an object. I hope you have a better understanding now about methods that return a variable of a reference type. Thank you for watching. Bye bye.